Okay, I'm back live here. Let me check my mic. Okay, I think my mic is working. Um, so we had to take a little break here from day 7. Let me pull up the documentation or the problem from day 7. So it is this packaging problem where we've got a bunch of descriptions of bags and what kinds of bags these bags can hold. And then we want to find how many bags uh, can contain at least one gold bag. So where we ended before I had to jump off here is that I had this, I was going to make a data structure that was a class, and then when I started coding it out, I'm like, no, I don't really need a class. I'm just going to use this dictionary here. So I can parse a line here that says like light red bags contain one bright bag and two muted yellow bags. And so if I do that, I'll get a dictionary that has these values here, light red, and what it can contain. So contain one bright white and two muted yellows. I don't know that I need the two muted yellows for this project part, but I imagine part 2 might have something that wants me to do that. So we'll leave that in there for now. So what I need to do is I need to now parse the whole file, and then I need to walk through this and see if any bag can reach a gold bag from it. So how am I going to do that? Well, I've got a key that maps to sub bags, and each of those map should be a key in there. And I'm just going to keep traversing through that until I find, if I find gold, and then I'll increment that. So I'll loop over all the keys, and then I'll have some function that says can or reach gold from that key, and we should be good there. So I'm sure I'll have a bunch of errors as we're doing this. This is probably like a classic interview assignment, and so generally that'd give you like some sort of tree structure. But like if you can do this, it's probably a good sign for like interviewing skills, I guess. So let's try and do this. I'm gonna walk through it, doing some testing along the way, and let's build this up. Okay, so I've got my input file here. So there's my input file, and so let's do like def parse file, and this is we're gonna pass in a actually, I'm not going to do file. I'm going to do parse lines. So why do I do that? I prefer not to have a file name be the interface if I can. Just makes it easier to test. So if I had a file name be the interface, then I've got to open the file, got to pull the data out of the file, and it makes it harder to test. If I want to test, I have to go out and make a file. If it has lines in it, then I can open a file easily, but then it makes it really easy to test. So I'm going to say the result is equal to a dictionary, and I'm going to loop over each line for line in lines, and then each line should be a unique key. And so I should be able to say res, and I think it's update, parse line of line, and then we'll just return our res. Okay, and so maybe I'll make a little main function down here, or I'll call it part1. So the first thing we're going to do is parse lines. So I'm going to say mapping is equal to parse lines, and I'm going to say open, and it's input.txt, and I'm going to say that my encoding is UTF-8, and let's So if I do that, that should be lines. What I'll do here is I'll just try this from the command line here. Say Python -i day 7. I'm going to say res is equal to part 1. Okay, let's look at the length of res. Okay, part 1 does not have anything. Oh, we need to return mapping here. So let's return mapping. Let's push it back up the hill. Length of res. Okay, 594. Okay, so now we need to traverse this thing. We can just loop over. So here's what I'm thinking. I'm going to loop over all the keys, but I'm going to keep another set, and I'm going to use a set for keys I've seen, and I might have two sets. One is one I've seen, and another one is whether this set can get gold. And then once I find a child that has the gold in it, I can just automatically mark that one, and I can mark it in seen, because I'm going to have to, when I loop over the children of the child, I'm going to have to, I might loop over them again. So whether I've seen them or not, we'll just optimize that so we don't have to worry about that. I guess I could do some sort of caching. I could use like an LRU cache to get that as well. So let's just sort of flush this out here. I'm just going to sort of try this out. Maybe I'll say like traverse mapping. Okay, and what will that look like? I mean, if I had, yeah, my Emacs is like really slow. I don't know what's going on here. I think I might spend some time later tonight updating my Windows for Linux. Don't like to do those sorts of things these days, but it's just not really responsive, which is silly. It should be really responsive here. Even like if I put it in fundamental mode, it's still not super responsive, which is weird. Okay, so if I were to traverse like this one, if I had data that was just this, it would say like light red, and then it would give me like a bright white and then a muted yellow. So it'd give me everything that I can reach from that, and then I don't have like what bright white would just assume that like bright white and muted yellow got to 0, and so that would be empty, and then I just need to check if gold is in the traversal here. So I'm going to have a mapping, and then I'm going to say for key in mapping. Mapping is a dictionary. I'm going to loop over all the keys, and I'm going to say, put this back in Python mode since it doesn't appear that the fundamental mode doesn't make it any quicker. I'm going to say seen is equal to set. Remember, I don't have an empty literal for set. I need to use the constructor to make an empty set. And maybe I'll say reaches gold is equal to a set as well. Anything that reaches gold. And so we're going to loop over each key. And then what I'm going to do is I'm going to yield the key. And I'm going to say, actually, if key not in scene, we'll yield the key. And then at the end here, we'll say scene.append key. And if key is equal to what we want to find, maybe I'll say like needle. and I'll just say that's equal to none. So we're searching for a needle. If we find a needle in our haystack, then we'll say reaches gold. Gold, maybe that's hard-coded. Okay, so after we've seen this, we're going to append it, and then we're going to do this. And then what we want to do is we just want to yield every key in our child, in the values there. So what I'm going to do here, I guess I could say for child key in, and I'm going to convert them into a set because they might have duplicates. And I don't know that I care about duplicates for this part. In set of mapping key. And then for each child, yeah, something is weird here. Okay, for each child in our child, yeah, maybe we want two functions here. We have like a traverse that's global, and then we do some functionality there. So how could we do this? I'm just thinking it might be cleaner if we have two functions here. Alternatively, we could do something where we have like a stack of nodes to look through, and then we stick those in. Okay, so I want to loop over every key in there, and then once I have a key, I want to loop over the children, and then once I have the children, I will loop over the children of the children. So this is a recursive call. So I think I do want a key in here. And maybe I'll pass in like seen and reaches. Seen. Reaches. And so this is going to be traverse mapping for key in loop children. We're going to loop over the children in mapping key. And okay, it looks like I'm getting some cello background noise. I'm gonna be right back. Okay. Okay, so we're going to loop over that. We've got our mapping. Children. Scene reaches needle. Not really liking this, but I mean, I alternatively I could go and like search breadth first search or depth first search, and on the internet and just copy and paste that code out of Wikipedia. I've done that before, and it kind of works. I mean, it's very easy to transform that to Python, but you know, I guess I'm working on this from scratch. So I've got my mapping, I've got the children. I'm going to pass in scene reaches gold, and I'll pass in my needle here. So this loop children, I want this to get all of the children for a key. So and then I'm going to say if needle in so I want this to return all of the children for a key. And then if needle in children we can just increment our count here. Okay, so here we're going to have a mapping, and we're going to have children. So let's make a list of everything we're going to see. I'm going to say this should be seen. Yeah, for loop in this. So we have the scene set, and I want to keep track of who's in the children here. Okay. For child in children, if not child in scene, yield child. And then we're going to say scene.append child. And then we say yield from and we're going to yield over each of the, we want to yield from loop children. We're going to do a recursive call with our mapping. And then the children would be mapping child. and then scene. So I don't think we need reaches and needle here. And then after each loop here, I think we need to reset scene to an empty set. Okay, well, let's try this and see what happens here. So I'm just going to add a test here for this. Okay, so we got, this is a generator here. I'm going to convert it into a list. Loop children. Let's see if I can get this down here. And I'm going to call with my mapping, I'm going to call that data. And data is equal to, I'm going to say A maps to B and D. B maps to C. And let's just do that. So here's loop over the children, and we want the children so this needs to be for key in for children in that. Okay, loop over the children. There's our data. Who are our children? I'm not liking this interface, but it looks like I'm sort of floundering on this one here. And who have we seen? We have seen the empty set here. Set has no append. So where am I appending here? That's add. Key error C. So if mapping dot get child, if we have children from this, we'll just get the grandchildren. Okay, we got BCD. That looks okay. B, C, D. Okay. So are we using needle here? Yeah, we're using needle. Are we using reaches? We're not using reaches. Okay, so let's just look at our code here. We're going to say traverse mapping. We're going to pass in a key, and I don't need to pass in a key here. I just need to pass in my mapping, and I don't need to pass in a scene. I just need to pass in a needle. And then for children in loop children, so loop children will be that. Okay. I'm going to push this up the hill, see what happens. So traverse mapping, that's what we need here. Traverse mapping, and what do we want this to be? Gold something? Shiny gold bag. Needle equal shiny gold bag. And we'll just print this. And let's go down here and do part 1. Okay, looks like we're in an infinite loop here. Yield from loop children. So why am I in an infinite loop? Okay, I guess we'll step into a debugger here. We'll say import pdb and pdb.set trace. Okay, we're going to step inside of this. So we're at part 1. Get our mapping here. Let's look at our key. So dotted blue. Look at children. Wavy green. Dull fuchsia. Plaid aqua. Okay. This is kind of hard to debug as is. So how can I make this easier to debug? One thing I can do is I can I've got seen, which is everyone I've seen. I guess I could look at seen. And seen is a set, and so maybe I don't want to use a set there. Maybe I want to use a list. It's going to be slower for doing lookups there, but I want to keep the order of what I've seen. And I need to say seen.add my key here. Let me just try this and see if this helps. Okay, so this is getting kind of long. Wow. Okay, the other thing I can do is as soon as I've seen this, I can break out of this loop because I don't need to look anymore. That's, let's let it run for a little bit. Vibrant gold. Okay. What am I going to do? I just need to debug this iteration here, and with the whole set, it's going really slow, which it shouldn't be. So let's, we've got our lines here. And let's just look at maybe the first, let's do like the first 3 lines. Let's just pull off the first 3 lines of this. So how am I going to do that? I say F width with this as fn. And we say lines is equal to fn dot read lines. And you're going to say lines 3 off the first 3 lines. Okay, so and then I'm just going to say print children and scene up here. I am really floundering on this one. Okay, so we got, and let's do head -3 of input. So we got dotted blue bag. Wavy green. So we got wavy green, and then we got pale beige. And then we got dotted olive. Oh. Hmm. Yeah, I am doing a floundering job of this. I'm gonna fail my interview here. Let's see. Huh. This is just weird. Okay. Okay, maybe I'll cheat. I mean, I'm trying to solve these from scratch, but maybe I'll cheat and I'll look up my breadth first search or depth first search algorithm. So I mean, it should be you add yourself, you return yourself, and then you return your children, and then you loop over your children, which I thought I was doing, but I've got some logic that's incorrect somewhere. Okay, well let's do this here. Um, So depth first, search. Maybe we'll do breadth first. Okay, so here it is. We've got our graph and our root, and we're just going to have a queue. We'll queue in our root. Okay, so I'm just going to take this and I'm going to port this to Python right here. And maybe I'm going to stop this video and I'll restart it just so the restarted one is the ported one. So we'll see you back. I'm going to end this one and I'll start a new one.